So a good way to become intimate with some framework or some application is to see how its makers wrote it. So I have here Laminas, formerly known as Zend, and we will look at how it uses 4 random design patterns internally so that we can learn how to use these patterns in our own code. So if we open up index.php here, this is basically the start of the application. Here is where everything happens. There are some declarations, and then there are some defining methods, loading from composer, autoload, retrieving configuration, and then there is this running the application, right? And here this application in it, we can see that it gets some properties, some configuration, and it initializes some properties. If I open this one, we can see that it uses the service manager configuration, set some services, set some configuration, and then at the end it gets the application itself and calls this bootstrap method with some listeners. And those listeners will listen to the events that are happening in our application. So if we open this bootstrap method, we can see that it basically gets the service manager, it sets up some listeners, and then sets some events, the MVC event, and then it triggers those events. But if we think about what these listeners and these events represent, we can see the internals of the observer design pattern or the subject observer pattern. And what this pattern does is it publishes some events in strategic places during the life cycle of the application. And then it allows different objects to react to that specific action, in our case, those listeners. For example, one action could be this event bootstrap that we have here. And this constant is basically just a string named bootstrap conveniently. And if we open documentation for Laminas for this event manager that we talked about here on the quick start, in the tutorial, we can see how this pattern actually works. It has an event that's a named action, right? That is what we are seeing over here. That's this event bootstrap, which is basically an action named bootstrap, right? Then we have the listener, which is any PHP callback that will react to this event. Here we have the listeners set up from the default listeners, and then the listeners that we are passing to this bootstrap with our init method. And then we have an event manager, which is basically orchestrating and connecting everything together. It knows about all the listeners and it will notify them about all the events that are happening, and it knows about all the events and it ties it all together. So for example, if we go into our module app, into our module PHP, and by the way, a quick disclaimer, I do not use Laminas professionally, and the last time I used Zend was in version 2, I guess about 18 years ago when I got my first job as a developer. I worked a bit with it Magento, but if you ever looked at the source of Laminas and it feels like some voodoo witchcraft, then this exercise is perfect for you looking into source code. It is just a PHP code in the end, and we will learn a lot by analyzing how it works. And actually analyzing different source code has made a huge improvements in my way of coding. I learned quite a lot of tips and tricks. So because let's be real, developers of Laminas are way smarter than both you and me, and particularly me. And I can learn a lot from smart people, of course. So I would advise you to do this exercise on your own and search for patterns and see how the information is being passed in. So if we go into this module.php and we can then put a method called here on bootstrap, and then we can put some just var dump here. If we now run our application again, we can actually see this code executed because this on bootstrap has been called on the bootstrap event. But what else we can do here is that we can register more events here that we are going to look at. If we follow this getting started tutorial that I have, we can just have some events from the event manager. And the event name, for example, be a, let's say, hack detected. And then we can tell it that when this event happens, we want, for example, to send email, we want to log this event, and then we want to display the message. We can just do a simple var dump here as well, saying that hack has been detected. Then if I would to run this code, nothing would have happened, of course, because I have just registered or attached the event, or more precisely, I have attached the observer to the event named hack detected. So later, some other place in the application, we can just dispatch this very event like they do in the documentation. We don't need any parameters for our examples, but we can just trigger the event hack detected, and we can give some parameters and things like that, and the target needs to be null. Now, if I run it, we can see that hack has been detected. and the application will actually do what we asked it to do in case of some event. So if somebody is trying to send some malicious data or hack something somewhere, change the IDs and things like that, so we can detect that and we can interactively call some of the events, and it will execute the code from above, sometimes later in the process. We are basically setting up some code that we want executed in case something happens sometime later. Now, obviously, this code needs to have a proper event manager like described in the application here. Then we need to register it, etc., etc. But I'm not doing the Laminas tutorial, so I will skip that part, as you can read it in the documentation. We are here just to discuss the observer pattern, how it works in principle. So the problem that the observer is trying to solve is when we have a situation where we have several objects that need to communicate with each other, but those objects do not necessarily want to be dependent on each other. In matter of fact, some of those objects might not even be present in some configurations, and this makes communication between objects a bit tricky if they are not allowed to know about each other. Let's say we have a post in some web shop application and it needs to communicate with some SEO object or some SEO module. And now having these two is fine, as they can just exchange information with each other. But if we would need to add a bunch more objects or maybe even plugins to our application, then those objects need to communicate with each other somehow. If they do it directly, like in this diagram, we can see how this becomes a mess pretty quickly. Luckily, some smarter people figured out a way of separating our objects with a middle layer, a mechanism that is for sure present in our application, so we are certain that it exists there. And that way, all of our objects will communicate only with that mechanism and not with each other. And this way, there is pretty much zero dependency between objects. So if we add or even remove some objects, nothing changes, as our objects do not care about all the other objects in the application. They will just publish and react to some events handled by the observer mechanism. And some objects are then observers and some are the subjects. So the SEO module would look for the changes in the pages, but some can also be the subject and the observer at the same time. So for example, the log will observe the SEO module, which will then observe the pages module, etc. So this pattern makes things extremely versatile, especially if you're working with plugins and custom modules. And by the way, these slides and a bunch more are from my PHP Design Patterns course on the applicableprogramming.com, where we use practical examples from real-life projects to learn how design patterns can prevent us from writing spaghetti code. And I mean real-life projects and problems, so no ducks or cars are used in the course. If you sometimes lose the control over your objects and your code becomes a bit too complex and you see that it's getting complex, check the link in the description for the course. I hope that it can help you with this. But this pattern, it is so important in Zend or now in Laminas that if we look at this run method in the application, and this run method happens right after this init, so it initializes the app, sets the event as we've seen, and it now runs, we can see that it doesn't do much here. It gets already existing events, it sets up the new events, it triggers the route event, and then it dispatches the event dispatch, and then it completes the response, so the event finish. And at the end, it just sets those responses back and it completes the request. So this method doesn't go in and find our main controller or the code. It's not as linear as you would follow it up and expect that this line calls the other line and then the other line calls the next line, and then you can find your own code that you've written. But if we look at this event dispatch, for example, and if we look at its usages, we can see that this abstract controller is actually attaching its own event named onDispatch to the event dispatch from the MVC event. And if we find this onDispatch here, we can see that it's being extended by the abstract action controller actually, and it has its own onDispatch method, which is actually doing something. And it will get the route from the URL, the one that we've typed in, and it will try to figure out the action by actually get method from action, right? By getting the method name with .action. So that way, if we in our application we write, the typical submit action or confirm action, something like that, that's actually figured out with this get method from action, and then this method would actually execute dynamically, and the response will be given back. But since our controllers, for example, the index controller also extends this abstract action controller, this method onDispatch we'll actually find all the actions here, and it will find this index action, or as I talked about, the submit control actions or whatever actions that we might have, edit action, delete action, everything like that. So that's the cycle it goes through in order to execute the action that we have. It's actually listening to all the events, and on appropriate times it's attaching listeners, and then it's executing your code. Quite cool concept if you are not familiar with it. And I again encourage you to dive a bit deeper into the source of Laminas framework, or pretty much any tool that you might be using, just to get familiar with its philosophy. Because again, you want to develop your code in the spirit of the tool, the framework that you're using. But again, the observer pattern is quite important in Laminas because, as we've seen, it's used internally a lot, and you will use it especially if you're writing some modules or plugins or any reusable functionality. And the same way is this module attached the on Bootstrap that we talked about. But if we go back to this very index PHP file and we actually look at this array utils merge, and what it does, it merges some value to the array. We can look at it and we can figure out this code, but that's not very interesting. And if we also look at this application in it, we can see that both of those are static functions or static methods, which looks like a singleton. It smells like a singleton, so it has to be singleton, right? Well, the definition and the purpose of the singleton is to have a single object throughout the application. It's usually implemented with the static methods, but it's not always that the static method is a singleton. Let's say that we have a database object and we want to use it in some multiple places. Obviously, we want to use it in our home, and then we want to use it in our About Us page, and then inside of our contact page. We need this database, right? Because we want to write and read from the database. And without the singleton pattern, we would just make a new object each time we want to use that database. And that means that it's very easy to open up multiple connections to the database. Or if we want to log some data to some server, we could open multiple connections to the same file, and the app would probably crash because operating system would not allow the same file to be opened by multiple resources, because you cannot write with multiple processes and it's complicated. But there are a lot of situations where we might want to have one and only one possible object of its type or of its kind in our application in its life cycle. In that case, we can use the singleton pattern and prevent new objects and resources to be opened completely if they already exist, if they are already open. And that way, in our database example, we can make one singleton class and then use it later when needed. And that way, our singleton class, we can just store the instance inside the class itself, and then we can just get that instance and use it in different places. And even if we call it multiple times in a row, the get instance will always get us the correct instance, where this get instance will be prepared inside of, for example, database init function or the method. So the Laminas does not actually use the singleton pattern, or it never mentions the singleton pattern in the documentation. And the only place where I was able to find the singleton was this registry.php, where it actually saves the instance that we talked about, and it has this get registry where it will create a new instance if it doesn't exist. And then there are some other methods that it uses, but even though it says that this is a singleton instance, you can see that it's deprecated, meaning that Laminas is actually moving away from using this implementation. This particular implementation is missing some ways, like making a private constructor, and some other places like removing the clone possibilities and sort of wake up from the memory and serialize and unserialize and things like that. Because basically making a true singleton in PHP is sort of like a hacking it. But using this way of storing instances in the class itself is one way of making a singleton, but there are other ways to achieve the similar functionality, and the closest way it achieves this singleton-like functionality is by using the service manager and sharing the services that are already created. So if you look at this service manager, in the configuration, we can see that it has actually this shared property here. And this parameter shared, which is on by default, will always return the same object of a service that already exists, that's already created in some step before. It's usually much faster and a cheaper way of using the services rather than making new object each time, because presumably you want one service to have its state shared in your application. And I said singleton-like functionality because a singleton cannot actually be created multiple times by design, while here inside this service manager, there's nothing preventing us to just mark something as shared to false and then create a new object. And that sort of defeats the point of singleton. And I guess there is a reason why majority of frameworks are slowly moving from making true singletons in PHP, because singleton is quite often considered an anti-pattern, meaning it's not a best practice, because in order to make it properly in PHP, we sort of have to hack our way into getting all the singleton-like functionality, and B, we are using one object or a class to do it, which also serves as a factory of its own state, and it's also a state management object, and it needs to do its own thing at the same time. And that makes it basically a bad design on purpose, because we want to have a single responsibility of our objects, right? And one more thing, PHP in general runs one script per request, so the singleton is not shared between requests or between all requests to the server, as it would be, for example, in one Java application. So in PHP, a singleton is not actually a true singleton, because PHP is not running all the time. And by the way, using design patterns is not Laminas related. Pretty much all frameworks, and even you and me, we use design patterns, and design patterns solve some already existing problems that programmers have been facing for decades, especially when working with object-oriented code. So knowing design patterns can help you very easily switch from framework to framework or to some new projects and understand how it works and how it should be used. So it's a useful thing to know and understand the singleton itself, even though the Laminas does not use them by the book, by the definition. So here in this run method, I noticed one thing that I get asked quite a lot from my students who are struggling to recognize patterns, or specifically to recognize the dependency injection design pattern in practice. And that's one of my favorite design patterns that I learned by actually analyzing the source code of CodeIgniter back in the days. But here on line 308, I've seen one thing that is perhaps interesting. Here we have this set name, set target, set response thing, assigning different properties or different values. They all look identical, they are all setters, meaning that they set some values. But if we go into this set name, for example, we can see that it sets this string name to a property name. And the same goes for this set target, because it can be null string or an object. But if we open this set response, which you will notice is not on M event, it is actually on MVC event, because it inherits the events. However, this set response does pretty much the same thing. It sets this response to a new response, right? However, the small difference is that set name, as mentioned, accepts strings or null, which means that nothing catastrophically will happen if the name is an empty string, or if it's null here. Our code might not work as expected, but it will not break, the application will not hang. Whereas if this set response, if we set something other than the response type, which is a response interface, which is again the message interface that has some properties here that are expected from it. If we send this response to something else other than the actual response interface, our code will break. Why? Because this response property is actually used in other places. So if we look at the use of this response, we can see that there is a get response, and this response is imperative that it has all methods that are expected for it. We can see that it's used on several places. And if we open, for example, this abstract RESTful controller, we can see that this response, when given back, it's expected to have this set content property, this setter, meaning that this very event, the MVC event that's getting response back, and all other classes in our application depend on this response being of this response type, or extending this response interface. So this get response and a lot of other things that are mentioned here on this MVC event are expected to be here, and even our editor knows that and sees that all these methods are available, because it's expected to be of that type, and that type contains all those methods. So again, if we set something else here instead of the this response in the setter, we will first of all foremost get the complaining from PHP that we are not using the correct type, and that's great. That's why interfaces help us with typing of our data. But if we somehow manage to trick the PHP into that one, or if we remove this typing here, we just put the single response, then PHP has no idea what we are passing in. And if we pass something wrong, as seen, this MVC event actually depends on this response being the correct type. So that's what the point of dependency injection is. And dependency injection can be used with the setter, which is considered as a soft dependency, meaning that it's not always needed. Only when we are about to use this response, we set it. But if we look in our application.php, if we find our constructor, we can see that, for example, this service manager, it has to be of service type, and that this application has to have a proper service manager injected to it, provided to it, so that it can work, because again, this service manager, as expected, is being used on different places. And we can see that, for example, this get method is expected on it to return some of the configuration that we might use. Meaning that the application will not even work, it will not even start, because right at the constructor here and line 100, it is expecting the proper dependency being injected and already configured, so it must be present for this application to work. In this case, the application object being name application, but any other object. If you have a shipping, then you need a shipping configuration object provided at the runtime of this or creating of that shipping object. And so the problem the dependency injection is trying to solve is by decoupling objects and allowing us to manually inject the dependencies that one object might need. What does that mean? Say we have a controller where we have a contact page, for example, which might work with a database. And now the database is using the Singleton pattern as mentioned above, but that's not important. What's important is that the contact depends on this database object, meaning that somewhere in the contact, somewhere in the constructor, we need to actually say, database, get me an instance of it, because the contacts cannot work without it. It needs data from database. So if we remove this contact from our application completely, and if we want to grab it and use it some other place, we cannot actually do that because it depends on this database. We have to move this database as well because they go in a package somehow. Now, in this case, with two objects depending on each other, this is not a big deal. But as we start adding objects and more services, we can see how this suddenly becomes quite entangled and related to each other. And each of those objects might relate to and depend on something else. The users might need the shipping and the contact might need the log, the database, etc, etc. So this makes development quite difficult because each object has to do their own thing, but also think about creating all these other objects and configuring the database and loggers, and even though they are singletons, it needs to reach out to them. So suddenly we cannot move any of those objects outside of its context, and we cannot test it because they all suddenly depend on each other. And it can even restrict us depending on configuration, so that we cannot even change the logger from log to file to log the database, because here we are explicitly configuring the logger in some specific way that we want to do it. So the dependency injection is a principle that allows us to make dependencies outside our objects, our consumers of our services, and then provide those dependencies into those consumers. Or we might even use the dependency injection service, which will do that for us. But simply put, we will create our database over here, and then we will create our loggers and shipping services somewhere in the controller, and we can just provide them and inject them when they are needed in some of our different modules, in some of our different places, in all of our consumers. We just give them, this is what you need to work with, and just do your job, do not think about it. And this means that we can change them programmatically. So we can, for example, replace our logger with a memory logger, with a file logger, database logger. The same goes for shipping. We can change the shipping based on the need, based on the location, the IP address of a user that's visiting or something like that. And those can be completely different objects. We might have completely different database and logger and shipping objects here that we are providing to our services, to our objects, because they work completely independently, and our objects, our user does not even care if there is a real database or it's a fake database or if it's a memory database, which also means that we can now take the user out of its context and we can put it in a test environment and simulate if a database is empty, if databases fail, if database does not exist, if logger is empty or something like that, and see how this user object behaves. What will it show, what data will it give, etc. So again, even if this code looks exactly the same, these setters here, the set name, set targets, and set response, we cannot recognize which of them is a dependency injection by just glancing at the code. We need to understand what our design patterns actually do in order to recognize them. And there are quite a lot of places where dependency injection is used in the Laminas code. For example, in this forward plugin, this controllers, for example, is being used some other place. So this controller has to be provided inside the constructor here. So this has to be of type controller manager, and it has to be provided, configured, and already ready for use when this forward is about to be initialized. And if we look at our application.php and its constructor, we can see that this application is used inside this application factory, again expecting to have all the proper get methods and things like that, because this factory actually needs all those methods to work properly, which is a nice segue in one more design pattern that we will look at today, and that is the factory design pattern. So here in this file, conveniently named application factory, we can see how Laminas actually makes some objects. And here you might say, well, there's nothing special about it, we can just make our own application manually, and that is true. But if we look at this factory interface, we can see that this factory interface is being used in quite a lot of places in Laminas. I believe that almost every service is actually being created through a factory, which means that Laminas uses this pattern quite extensively, and if it uses quite extensively, we should look at it and understand why it does it and how it works. For example, this forward pack factory here, it has some logic here that configures how this forward plugin that we mentioned is actually being used. And for example, we can look also at this the exception strategy factory, which is actually a strategy pattern as well as the factory. And the strategy is relatively simply just chooses the correct way of implementing something. Well, a correct strategy based on some parameters, but I will not go into the strategy today, as I see that this video is getting a bit longer as it is. And strategy is, by the way, the next module I'm working on my PHP Design Patterns course. And there we build the most popular patterns on our own, so you also can see how I build it, but you also get the homework with real life examples, how to build them yourself. So again, no ducks and no cars are used in the course. We also analyzed these patterns, how to use them actually in the applications and frameworks. And I will link the preview of the course and some more design patterns explained so you can see for yourself and learn much more. And again, this strategy factory actually chooses some strategies based on some configuration where there are some exceptions with the true or false, sets the display flags, sets the dependencies and things like that we talked about. But the point of factory, as we've seen in our example, is to make some objects, as simple as that. And we can do that ourselves, as said, but some more complex objects have a bit more complex way of configuring and actually making them. Say we have a controller that might need make a shipping object. So it might provide it with some parameters it needs in order to work, like username, password, start address, etc. Things that usually objects need when created, especially external services. Now this is great, but the problem is usually is when we want to do this code in multiple places, thus creating a lot of duplication. We might to have multiple different objects, and we might have one way to configure one object and a different way to configure the second object, and then a third way to configure the third object, etc, etc. And also we might need to have a way to determine which actual object we want to make, so we need somewhere to put some if-else and some logic that will give us the correct object based on some parameters that we might have in our application. And this code already looks quite ugly, so when we need to have this code in multiple controllers, so everything needs to be duplicated in several controllers, we can see how it becomes a mess and duplication of things quite fast. Especially when some of these objects need to change, for example, and we might have to change the config parameters for this one or to change this method or something like that. We have to now hunt it down in our application and try to figure out where each of those is being used. And you see already that it's a mess. And that is where a factory comes in, and its job is to give us the proper object which is already properly configured. That way we do not have to think about generating our objects. We might have to prepare dependencies, configuration, and we can even give the factory some strategies that it will use, so then it can focus on actually choosing which one to use, the strategy as we've seen in our example. But we can also have the different ways of creating some of the objects that this factory knows about, so that it knows how to configure each of those objects on its own. But even if it doesn't have to choose, it's good enough to just avoid copying this configuration in multiple places, so we can just focus on our business logic and we don't have to hunt it around and change it in multiple places. So for example, if we look at this HTTP method listener interface, There is again a logic that will set some properties based if some configuration is being enabled or disabled, set it to true, to false, and configured all the dependencies, etc. that some object might need. We can also have multiple factories for same service. Say that we have a image service and we might have JPEG or GIF service, GIF or GIF services, factories to configure that object for a proper way of working. If we are, say, shipping the physical or digital products, we might have different things of configuring the shipping service, etc. So we can say that some shipping service suddenly becomes a digital shipping service, where it will always return 0 for the price of the shipping, right? But this factory pattern is also used in conjunction with dependency injection pattern that we mentioned above, and it gives mechanisms to Laminas to create services for us when we need them. For example, by calling this create method with create instances in the dependency injection here. So dependency injection also supports factories that will let service manager know how to make us a service. So that way dependency injection knows exactly which factory to use in order to give us the proper service that we might use. And as we have seen in the source, we can see that Lamina uses the factories a lot. I hope that you learned something interesting today, and watch my course preview to learn about dependency injection or these other videos on how Laravel uses design patterns internally. Bye!